Hello, this is our Aerospace Measurements final project. Our team name is the project team. My name is Henry Bright.
Hi, I'm Michael Cece.
Hey, I'm Joanna Grant.
And I'm Laz Nasad.
To begin, we want to explain the goal of this project and the requirements to fulfill it. So the goal of this project was to use the Arduino platform and the kit that we were provided in our lab, which included a breadboard with input-output data and sensors to measure temperature and distance. So we had several lessons from the manufacturer that we had to complete to assess the sensors and be able to find error and determine all of these measurements. And then also integrate some of these systems together so we were able to use like the motor and the sensors in conjunction, relevant to different applications for measurements. So I will pass it off to Michael to explain the strategy to accomplish these goals.
Yeah, so basically we followed the lessons provided by Arduino, the manufacturer of the project. And using the circuit board, we obtained data over a defined integral. And once it was collected, we could then analyze the data to describe any errors that were present during the experiment. So we'll go on to the circuit diagrams. All right, so lesson 13 involved the use of the servo. Lesson 11. Lesson 13 was the water depth measurement. Lesson 14 was the ultrasonic sensor. And finally, lesson 21 involved the temperature measurement device. So I'll pass you on to Joel Negron to finish the design steps.
All right, so first we wired each lesson to check that they worked with the code. Then we went back and started wiring the hardest lesson, which was the temperature with the 21 pins, since it had the most probability of having the most errors or any wiring issues with the wires or the LCD. And then the issues we ran by were some of the code in the US sensor was wrong, especially in the trigger, had the wrong pin. So we needed to switch the pins to the correct one in the Uno. And then we also ran into an issue with the LCD not showing any numbers or temperature measurements. So we needed to turn and adjust the potentiometer to show the numbers and adjust the brightness. And also the code for the temperature was not showing in the serial motor and we wanted to show, so we coded it in so we could check that the temperature in the LCD was actually reading the right temperature. And also in the temperature, we found that the connections from the female to male wires to the thermistor were not having the best connectivity to the water. So we needed to tape together so that it had better connectivity to show a more accurate reading in the temperature. And now off to Alasna to show the calibrations.
Calibration in this project is super important because we're using lots of sensors along with an Arduino board to check the different data. And without proper calibration, we run the risk of all of our data being wrong. Next slide. Here we are calibrating the temperature sensor. We do so by checking the temperature of hot water using an actual thermometer and making sure that the temperature sensor reads a similar reading. Next, here we are calibrating the servo motor. We do this by checking the rotation of the motor. Here we are calibrating the water depth sensor and making sure the distance is correct. And finally, here we are calibrating the ultrasonic sensor by using a notebook and checking the distance from the sensor. Now off to Henry with the significance.
Yes, so ultimately, the lessons that we were able to learn from this project were several things that are going to be relevant to skills that we'll need as engineers. First of all, the coding experience was very important, getting to use the Arduino boards and being able to make sure that we use the lesson code and integrate that code so that we have systems that can work well together, using, like, for example, with lesson 21, using the servo motor with the water depth sensor, we were able to kind of like combine lessons together. Another important skill was wiring the systems. So being able to learn how to use the input output with the breadboard to wire everything together so that we get accurate results and are actually able to get results. And then again, integrating systems is critical. And anytime we're going to be doing measurement systems and we're going to be doing more complex engineering design problems, we're going to need to be able to integrate these systems together. And then through calculations, we were also able to learn a little bit about error, looking at like the hysteresis and the zero shift error. We were able to kind of analyze that compared to, other measurement systems, like with the temperature sensor where we had the thermometer. We were able to compare our results and make sure that we're getting accurate enough results within a tolerance. And then relevant to the engineering field, a potential task that we might be able to do in the field that would be related, use related skills is we may need, for example, to have a controller that could measure the water depth change in a manometer. If we were able to do that successfully, we could potentially measure the pressure in like a wind tunnel. This would just be one example of a way that we could use some of these principles. So that completes our discussion on this final project.